Hello class, today we're beginning chapter 7 and we're on lesson 1, simultaneous equations. And let's start reading from our text. The tallest man in the world is reported to be Don Kohler of Chicago, Illinois. He is shown in this photo with Mihaly Massayeros, who works for the Ringling Brothers and Barnum and Bailey Circus and is one of the world's shortest men. Can you figure out how tall each man is from the following clues? The sum of their heights is 131 inches, and the difference of their heights is 65 inches. Now, if we let x and y represent Mr. Kohler's and Mr. Massayeros' respective heights in inches, these clues can be translated into the equations x plus y is equal to 131. Let's put that up here on our board. So we have x plus y, meaning x being Mr. Kohler, because they did say respective heights. They said x and y, then they put it in the same order, Kohler and Massayeros. So let's go x plus y. We know both of their heights together are equal to 131. Now we're also told that the difference of their heights, x minus y, is 65 inches. It's equal to 65. Now let's pause for a minute and say, why did we do this? Well, first off, we know x, the tallest man, okay, Mr. Kohler, when you subtract the height of Massayeros, you'll get 65. So that's why we put them in x minus y order, because we know the taller minus the shorter. Now, pictures illustrating these equations are shown below. So if you take a look, they have a picture of the two gentlemen, and I will attempt to draw the tall one as a stick figure. Okay, so we're going to have a stick figure over here. Okay, and there's the tall gentleman. All right, and then they put the shorter gentleman on top. All right, so they put him above. So this is sort of like you're stacking them. And we know that the height of the first gentleman, the tall one, from here to here, let's say, is x. And we know that from here to here represents the height of y. And we know we can write, just say right next to it here, they do it from left to on both sides, but we know that this is equal to 131. So you could see that x plus y is equal to 131, which is why we have this equation. Now, if we took a look at the other, we could take the gentleman here and drop him down to here. I don't have to draw the tall one again. So if I have his height, okay, and we know that his height, okay, is y, right? And we'll just put that over here. Now we know that the height of the taller gentleman, Kohler, is x. Okay, so let's just look at this and this, these two illustrations. Forget about the 131 in the middle. And we know that the difference is 65. Okay, which means that x, if we have this whole distance minus y, we'll have 65 left over. So that's why we have this equation. Okay, let's take a look at the top of page 285. Because we're working on two equations at the same time, we will call them simultaneous equations. Now, just one thing to note, that in these equations, when we call them simultaneous equations, what we're basically saying is that these x values and these y values are actually the same value. We just don't know what they are. Okay, so that's why we can call them simultaneous equations, because they are actually in reference to the same thing. In this case, we're saying x plus y is going to equal to 131, and that same x and y, x minus y, is going to equal to 65. Now, if we took two totally independent equations, we can't make that assumption. We're using these values of x and y as specific values that are the same value. So we have Mr. Kohler's height plus Mr. Masiero's height is equal to 131. And likewise, we have Mr. Kohler's height minus Mr. Masiero's height is equal to 165. So that's what makes them simultaneous equations, okay? Just kind of bringing you in to understand that these x's and y's are the same value. And again, if we had a totally different sets of equations, we wouldn't necessarily be able to do this unless we were able to ascertain that the x value for both equations are the same, and as well as the y. Now, to solve them, we must find an ordered pair of numbers that can replace the variables in both equations to make them true. One way to do this is suggested by the picture below. Although it is merely the two pictures of the facing page drawn as one, it suggests another equation. Well, let's take a look here. We have a picture here of Mr. Kohler at the top and Mr. Kohler at the bottom, right? And we also have Mr. Masieros next to Mr. Kohler and the 165. So we really just took both of these and sort of stacked them onto each other. Now notice that by stacking them, we're creating one big equation. We're adding the two simultaneous equations. And we can come up with, here we have x plus x is equal to 131 plus 65. Now, how can we say that? Well, let's pause for a minute and and go back over to our equation here. Hold on, I'm going to move over. So let's go ahead here, and I'm going to actually redraw the picture so that we can really see much more clearer. We have an x, all right, and that's the height, and we have the x here. I'm not going to redraw the picture of the men, but I do want you to be able to see why we came up with this equation. Now we see, if we look on the right side, we see that the two men together, right, their height, which goes all the way up to about here, all right, and actually I shouldn't have drawn that whole line. I just draw a partial line, put the 131 in there, and go all the way up to here, which includes Mr. Masiero's height, right? We see that goes up to 131, and then we have 65. So if we were to put these two equations together, or let's say the illustrations first, we're able to determine that, as we said, x plus x is equal to 131 plus 65. And again, take a look at the left side. We have the tall Mr. Kohler at the top, and we also have Mr. Kohler at the bottom. So Mr. Kohler is represented by the two x's, but we also see that Mr. Kohler with Mr. Masieros on top plus the 65. These all added together will give us a value. When we add x plus x, we're going to end up with 2x is equal to 196. And we would divide each side by 2. We would get x is equal to 98. So now we've been able to determine that Mr. Kohler's height is 98 inches, or 8 feet 2 inches tall. Now, knowing this, we still haven't determined what Mr. Masiero's height is, because we've only determined what x is. Okay, now I'm just going to pause for a minute and clear up our board here. Okay, I've magically made that disappear. Now, let's take a look again and say we can replace x by 98 in either of the original equations. Remember, we have two equations over here. Let me get my pen back and explain to you. We have x plus y is equal to 131. Now we know what the value of x is already because we've determined that down here. Okay, so we have x is equal to 98. So I can go back into either of these two equations, and let's take the first one and simply put in the value of 98 plus y is equal to 131. And we now can just subtract 98 from each side, right? And what will we get? Y is going to be equal to 33. Now, Mr. Macieto's height is 33 inches, or 2 feet 9 inches tall. And you could see just by the photo, it is considerably much shorter than the tallest man. Now, we can check our answers in both of these by simply plugging in 98. Obviously, we have it already here. 98 plus 33 is going to equal to 131. And if we have 98 minus 33, well, that will equal to 65. Now, we found the solution to the simultaneous equations. In other words, we have the ordered pair. Remember, ordered pair x and y? We know what value actually makes both of these statements true. If you plug in 98, and let's just go ahead and write that ordered pair, it would look like this. You know, we've been doing this with our graphing. Well, we're not going to be graphing. Oop, put the 33 in there. So we have 98, 33. 98 and 33 are that's the x and y, that's the ordered pair. And this would be the correct answer for both of these equations. Now this equation, we did it using an illustration. I don't expect you to be able to do that illustration. It's a little bit difficult for us to sit there and draw figures all day long so that we can solve math. Sometimes it's good to have some illustration, but in this case we're going to show you really what we just did. This equation was suggested by illustrating or by a picture illustrating the first two. Is it possible to write this equation without looking at this picture? That's really what's most important. So this might have been a little confusing. If it was, we're just going to turn the page over and you're going to see basically what we did. And this is what we're going to be focused on this chapter. The answer is yes. Page 286. We can get this equation by adding the left sides of the first two equations and adding their right sides and setting the sums equal. So let's take a look at what they did. They simply added the two equations. We have x plus y is equal to 131, and we have x minus y is equal to 65. Now notice we have a line drawn underneath it, as if we were just adding these, basic arithmetic, little plus sign over here, and what we're going to do is we're simply going to add these as they are, including, we're going to put the equal sign there. So what do we get when we add x plus x? We get 2x. What happens when we add positive y and negative y? Note that we have a plus and a minus here, and we'll go a little further into that now going forward as to how the symbol to the left is always applied as part of the properties of the variable or whatever the term is to the right. So we have plus y, that's a positive y. We have negative or minus y, this is a negative y. And again, you know, we can turn this into x plus negative y. So we're just looking at it straight ahead now without changing the equation, and we know that plus y and minus y are going to be equal to 0. They cancel each other out. Positive y, negative y. Positive 3, negative 3. So we can move over to the right, and we can now add 131 and 96, or excuse me, 65, and we get 196, which is what we had over here. You see, we had x plus x is equal to 131 plus 65, and we ended up with 2x is equal to 196, which is what we have here. Now we're able to solve this, we know, and we would certainly get the same answer. X is equal to 98. And again, we'd be able to follow the same process as we did before, putting in the value of x into one of the original equations, and we can then solve it for the other variable. So if the first two equations are true, then this equation must also be true. we will call this method for solving pairs of simultaneous equations the addition method. Here's another example of how it's used. So we have an example here, and I'm going to clear my board again. Okay, we now have a nice clear board. We can take a look at this example. It says write a pair of simultaneous equations, the first in terms of addition and the second in terms of subtraction, relating the lengths of the line segments in these diagrams. Then solve the equations for x and y. Okay, so let's go ahead and do as addition. Okay, terms of addition, what would we have? Well, we have the equation x plus 5y, because if we take a look at our picture here, or I'm sorry, our illustration, we have an x and it's followed by 1, 2, 3, 4, 5 y's, and that's equal to 33. So we can say x plus 5y is equal to what's below it. Okay, and now we can also say the next equation, we have x plus x, right? And this is a little bit tricky. You have to be able to understand that x plus x is the length of the top part. We're in the second diagram, and then we have running across 1, 2, 3, 4, 5 y's and a 6. You might say, well, the equation there would be 2x minus 5y. Now let me explain why, just in case you're confused why we would write it this way. And I'll give you a simple example. All right. Let's just take this simple diagram and say this is 10, right? And let's say we have this being 7 out to here, and then this is just 3. So we see the three values here. We have 10, we have a 7 plus 3 is equal to 10. So if we added the 7 and the 3, we'd get 10. But we also know that we can subtract the 7 from the 10 to give this answer. So if we didn't know what this answer was, for instance, all right, let's say x, right? What would we add to 7 to make 10? Well, we know that simply is going to be 3. But if we didn't know, and let's say it was a much more complicated scenario, such as the one that we have, we know that we could simply subtract the 7 from the 10 to say this is what's left over in this section. Okay? So that's why we were able to construct this equation. And it's just a little bit of practice. It takes practice to recognize those opportunities. But notice they did say the first one should be in terms of addition and that the second one should be in terms of subtraction. So now we have two equations, and these are simultaneous equations because the values of x and y in this particular case are the same. In other words, we're dealing with the two equations that have something to do with each other. Okay? And we're going to look here and say, adding the left and right sides of these equations to make a new equation, we get x plus 5y and equals 33 plus, so I'm just going to draw a line here and put my plus sign here. Now, we're going to solve this using addition, using the addition method. And what's going to happen is, well, we have x plus x is equal to 3x. Well, that 3 is not as 3-ish as it should be, so let's make it clearer. And when we add positive 5y and negative 5y, well, they're going to cancel each other out, so to speak. And so that will be 0. And we have 33 plus 6 is equal to 39. So now we have 3x is equal to 39. And we know that if we simply divide each side by 3, we know that x is going to be equal to 13. Now to find y, we substitute the value of x into either of the original equations. And I always suggest try to find the easier one. Now if you look here, this one is simply x, this one is 2x. There's a little more work here. I would probably choose the first one and simply say 13 plus 5y is equal to 33. And then I would solve this by subtracting 13 from each side, I would have 5y is equal to 20. And if I divide each side by 5, y would be equal to 4. So our answer for this particular, for these two equations, what would be the same answer that would make it true? The one answer that makes both true? Well, that would be x being 13 and y is equal to 4. So that's our ordered pair. Let's just call it. Again, we're not graphing these yet. We will be using some graphs so we can show you exactly why this works, because we understand that when we have an x and y value, we understand that to be a solution, and we know that the entire line is a solution. There are just infinite numbers of answers just within the line. But picture these two different equations going in different directions, but they cross at one point. Well, that's basically what we're finding here. So if we had a graph drawn up on our board, and again, this is just an example, it's not necessarily the graph of this particular of these equations, and let's say one was a line going this way and another one was a line going this way. This particular point right here, if these were the graphs of these two equations, this point would be the answer, which is basically what we're looking for here. And again, I'm not saying that this is that one. This is just an example. Just want you to visualize. So we can see that we can also check this value. Finally, checking these values for x and y in the second equation, they simply took this one, they plugged in the values, 2 times 13 for the x minus 5 times 4 for the y is equal to 6. 26 minus 20 is equal to 6, and 6 is equal to 6. So we can see that this is correct. It's always good to check your work. We can make simple math mistakes or math errors, and those will come out if we check our work. So that is the end of your first lesson in Chapter 7.